Right, we started this lesson by looking at this little video on YouTube, which was some footage of some astronauts in the International Space Station, I think. And the big question was, what causes this feeling of weightlessness that they are obviously experiencing in space? Okay, right, and this is a very, very common misconception. It's a very, very common answer for people to say, well, of course, there's zero gravity in space. And that's couldn't be further from the truth. There's lots of gravity in space. In fact, the Earth's gravitational field does extend quite far out, certainly as far as the moon. Otherwise, the moon wouldn't orbit the Earth. So, what's going on? Why are astronauts appearing as though there's zero gravity where they are? Okay. Now, the answer is a little bit more complicated than there's no gravity. Now, the answer is they're actually in what is known as free fall. So whenever astronauts are in the space shuttle or the International Space Station, they're in something called free fall. Now, what does free fall mean? Imagine you're in an elevator, okay? And imagine that the cables snap. All right, what would happen to that elevator and what would happen to the person in there? Okay. Well, obviously, the elevator is going to fall to Earth. The elevator is actually going to accelerate towards the Earth. But what's going to happen to the person inside the elevator? Well, the person inside the elevator is going to accelerate towards the Earth at the same rate as the accelerator. So, what happens, or what would hypothetically happen, is they would appear as though they're floating in the space within the elevator. Now, that's what's known as free fall. They would, in fact, experience, albeit for a short amount of time, the feeling of weightlessness. And that's exactly what is happening here with astronauts in space. Okay, but you might be asking now, well, if that's the case, then why don't astronauts in the space station, why don't they fall to Earth like the guy in the elevator? Right? The answer is they're actually moving in orbit. It's as simple as that. Right. So here we have the Earth orbiting the Sun, the Moon orbiting the Earth. Okay, they're in a circular or near circular orbit. All right. But why doesn't the Moon fall to Earth? Or why doesn't the Earth fall towards the Sun if they're in free fall like the guy in the elevator? Now, the big reason is because the moon, so let's look at the moon first. The moon is actually moving in that direction. Okay? It's feeling a force in that direction. The Earth is pulling the moon towards it. But the moon is actually moving in the direction of a tangent to the circle. That's what the moon is doing. It's actually moving in that direction, but the Earth is pulling it towards the Earth. So the result is that it actually moves in a circular orbit. Okay, it's because the pull is at right angles to the direction it's moving. So the result of that rather, is it moves in a nice circular orbit. Okay. Now you might be asking, yeah, okay, I like that. However, why doesn't the moon maybe spiral towards the Earth? Okay. If the moon's moving in that direction, why doesn't the moon kind of do this then? Okay. Which would be a very valid question. Now the answer can be got from a very famous thought experiment. A very famous thought experiment by Sir Isaac Newton, who hypothesized that if you had a gun or a cannon at the top of a very tall mountain on Earth, and you fired a cannonball, okay. Now there's three scenarios here. First scenario, you fire a cannonball quite slowly. The cannonball would basically fire out at a tangent initially in that direction, but it would also fall to earth like that. Okay? What if you fired the cannonball a bit faster? Well, it would fall to earth like that, wouldn't it? Now, he reckoned that if you fired the cannonball at just the right speed, just fast enough, that it would indeed fall to earth, but the surface of the earth would fall away at the same rate, and the result would be it would move in a perfect circle around the earth. Okay? Now, that you only get an orbit, you only get a perfectly circular orbit if that cannonball is fired at just the right speed. In fact, if you fire it faster, what's going to happen then? Any ideas? If you fire it even faster than V3, that cannonball is going to do that, isn't it? So there you have it. That's what causes objects to move in a perfectly circular orbit, even though the force is perpendicular. Look, the force on these balls is always towards the center of the earth. Okay? Doesn't matter where this ball is. This ball could be here. The force is towards the center of the earth. When the ball's here, the force is to the center of the earth. But because the one fired at V3 is fired at just the right speed, it actually goes in a perfectly circular orbit. Okay, right, thank you very much. That is why things don't fall to Earth. That is why the moon does not spiral in to the Earth. That's why the Earth doesn't thankfully spiral in to the sun. Okay, it's all because they're moving at just the right speed. Okay, the moon is moving at just the right speed. Just the right speed. That as it falls to the earth, the surface of the earth falls away at the same rate, so it actually moves in a perfect circle, exactly like the cannonball fired at the speed V3. Right, thank you very much.